We're going to solve this system for the force F. There's three tools to use when solving these systems. Sum of the moments at any point equals 0. Sum of the forces in the x direction equals 0. And sum of the forces in the y direction equals 0. So we start off by using the sum of the moments about P equals 0. We'll start off with a tricky one. We'll start off with F. Now F will have two components. A component in the x direction, pulling that way, and a component in the y direction, pushing down that way. That component there is F cos 20. This one is F sin 20. Okay, so we start off, we have F cos 20 times, that's F cos 20 times its distance, the perpendicular distance to the fulcrum is 650. Now that's pulling that way, that's clockwise at that point. Now we have the y component is F sin 20, which is pulling down that way, which is pushing it anti-clockwise about that pivot point. And the distance is 150, anti-clockwise negative, so that's times 150. Then we have this force here, it has a y component, which causes a moment. It has an x component as well. The x component is no distance, so it causes no moment about that pivot. Okay, so the y component of the 500, so that's 500 sine 60. It's causing it to spin anti-clockwise, so it's negative, and the distance is 950. Final component comes from the 600 newtons. Again, anti-clockwise, so it's minus 600 sine 60 times 1850. Okay, and all that equals 0. So that's 61, multiply this out, that's 610.8 F minus 51.3 F minus 411400 minus 961,300. All that equals 0. Solve that line. We get F equals 2450 newtons. When you have a question like this, the starting point, 9 times out of 10, is taking moments about the hinge. Okay? Moments about the hinge. Okay, we've solved and we've found what F is. We've used the sum of the moments. Now, we want to find the horizontal reaction from the tractor and the vertical reaction one up here as well. We're going to use, first of all, some of the forces in the x direction. So 2450, it has an x component of 2450 cos 20. Okay. It's going in the positive x direction. There's a positive x direction. And there's a positive y direction. 500 is also in the same direction, so it's 500 cos 60 plus 600 again cos 60. The RH is going in the opposite direction, so it's minus RH. That all equals 0. So if you do the calculations, solve that, you find that the horizontal component equals 2852 newtons. That's solving it for the horizontal direction. That was using the sum of the forces in the x direction equals 0. So now use this formula. The final step is to use the sum of the forces in the y direction equals 0. So we have 2450 sine 20 Now it's acting down the way. The y component here is acting down the way, so that's negative. 500 sine 60, again acting down the way, so it's negative. And 600 sine 60, again acting down the way, again negative. RV, however, is acting up the way, so it's positive, and that equals 0. Total that lot up, and you'll find that RV equals 1791 newtons. Now you've got the horizontal component. Okay, it's positive, so the arrow direction was right. So the horizontal component's coming like that. RV is also positive. It's going up. Use Pythagoras to find the resultant and find that angle there.